Welcome, everyone. I'm really glad to see so many people coming in. This is probably the biggest in-person event that we had for a long time. Really glad to be here. So welcome for the Menken Distinguished Lecture in Population Studies. This is very timely. Welcome, Jane. So good to have you. And Dick with her. Wasn't even aware you're walking there. That was perfectly timed. The Jane Menken Distinguished Lecture, for those who don't know this yet, is happening every 2 years, every other year. That's exactly, or at least the plan as we do this. For those who don't know Jane, I bet there are very few. Jane Menken, that's how the official role is, sorry about that, Distinguished Research Professor Emerita and past Director of IBS, a very influential Director of IBS, as most of you might remember, and still very active, very present in IBS, and we're very glad about it. She has been tremendously influential on the global scale, regional scale, local scale, in her field of studies on human fertility and reproductive health. Again, as most of you know, that's where she was incredibly influential in the past and in the present. This distinguished lecture is held twice or every other year, as I mentioned before. COVID has taught us things are not as plannable sometimes, but we are more or less intact with theory. Anyways, we are really thrilled to welcome Dr. Deborah Balk as our invited guest speaker today. I will talk more about Deborah and introduce her in just a few minutes. From the City University of New York, and you can see the title right here, Confronting the Rising Tide, Population Exposure, Change and Prospects in Low-Lying Coastal Areas. Before I go there, I want to welcome a few people. Chancellor Di Stefano, welcome, so good to have you. Vice Chancellor for Research, Massimo Rosini, good to have you. And our Arts and Sciences Dean, Glenn Krutz, right there in the back. Thank you, gentlemen, for coming. It's an honor to have you. Before Massimo saying a few words about IBS and about us, the most important part is thank you so much, Annie, Marjari. Thank you so much, Angela Branson, for all the help for making this event actually possible. Some of you might be able to imagine how much work there was. Thank you so much. All right, so the plan is Massimo will talk a few words. After that, Laurie will introduce Jane in a little bit more depth, in a lot of depth. And after that, we go from there. Massimo, thank you.
Well, thank you. Thank you for having me here. And it's great to be at this lecture and to have the opportunity to interact briefly with the IBS community. And it's it's been my pleasure to get to know this institute in this role. And as you know, IBS is one of the 12 institutes at CU Boulder. And from my admittedly biased view, the institutes really formed the network of interdisciplinary research at CU Boulder, upon which we built a very incredible footprint in research at the national level, which I'm really proud to represent whenever I can. And I really enjoy working with Laurie on some of the strategic initiatives that we're trying to push to help the institute increase the impact that the institute has on campus and beyond. Just a little anecdote, about 2 months ago, I traveled to DC and meet with agency representatives, and I had lunch with the deputy director of ARPA-H, which is a brand new agency that's formed with a very large budget. And in sort of apologizing, I said, I hope we're having a good meeting because we don't have a medical school at CU Boulder. And he said, well, I know, but you have behavioral sciences is really strong. And so I'm glad that we're talking. And so that is always a very strong validation of the reputation of the institution outside of what we see. So I think your work is, your scholarly contributions are really important for us on their own, but they're also very complementary to other disciplines in thinking about business, engineering, economics, where behavioral science are always very important in coming in. And so the work they do is really impactful on prevention of violence, the interaction of the environment and the population, which is the topic that I'm looking forward to learn more, and natural disasters and many more. So I'm sorry for leaving some out, but it's really a great institute that we have and we're really proud of. So in closing, the Research and Innovation Office is proud to be here today, and I'm representing that office. And I also want to acknowledge Jane for her contributions to the Institute, to our campus, and looking at your resume, it's like very humbling and and obviously your contribution beyond Seabold. So thank you for having me, and I'm looking forward to the event today. Thanks.
Thank you, Massimo. I'll say you thought I was humbling. I had to try to summarize her resume in like 2 pages. But I'd say also thank you to Massimo for being here. Really appreciate it. And thank you, Phil, for being here so much. And thank you, Glenn, for being here too. Really, really appreciate you taking the time. And I also want to acknowledge and appreciate Annie and Angie as well, who have made this happen. So thank you very much, gals. So I'm to introduce Jane. Stefan already mentioned, distinguished professor here at CU Boulder, led the Institute from 2001 to 2015, very influential period. She's had an extraordinarily impactful research career, and she continues. So an absolute pioneer in her field. Jane was one of the very first to mathematically model fertility back in the 70s with her mentor Mendel Chefs, and she kept that work going, continues to do that kind of work today. In the 70s, she was a critical member of the establishment of a demographic surveillance site in Bangladesh. It's actually the longest running surveillance site in the global south. That surveillance site has fueled work on so many important topics. I mean, health service delivery, vaccines, health interventions. So it's not only Jane's body of work, but the capacity that she's built that has been tremendously impactful. So she visited that site for months over the course of 30 years. And that's the commitment and incredible contribution of Jane. So lest you think that she has slowed down, Jane is now a central member of the Colorado Fertility Project, which is here at IBS, funded by NIH, led by Amanda Stevenson, where they are doing critically important work, looking at the ways in which access to contraception influences women's life trajectories. They're all over the news right now for reasons I can imagine that you understand. Also critically important, I already mentioned capacity building. I want to talk just a little bit more about that. All those trips to Bangladesh, she didn't go alone. She took along her protege, right? Students and postdocs from Princeton and Penn, where she was before here. All sorts of Boulder students and postdocs have benefited as well. Jane acquired, so another example here at CU in 2001, she got resources from the Mellon Foundation, the Hewlett Foundation, and NIA to establish an Africa-focused population and research training center here. That really connected with the African Population and Health Research Center in Nairobi, the University of the Witwatersrand in South Africa. And that center was part of the reason that we've been successful in garnering NIH funding for the CU Population Center. So it's like this domino effect. You get Jane involved and stuff happens, right? So let me say her contributions have been recognized in many ways. She was elected to the National Academy of Sciences in '89. She chaired the Academy's Committee on Population and also their working group on aging in Africa. She was named to the American Academy of Arts and Sciences in 1990. I'm just going to do 2 more. President of the Population Association of America in 1985, and a laureate of the International Union for the Scientific Study of Population. That's our main global professional association, and being a laureate is top dog, right? I mean, that means that's top dog. And that's you. So here, this is what I'm going to do because there was like so much. So I'm going to talk about the rest of it in spatial terms is what I decided. Looking at Jane's CV, page 14 starts her publication list. Which is huge. All of the pages before that are single-space list of awards, honors, consultancies, committees, panels, 14 pages. So this is why I could go on for a long time, but I'm just going to give you that spatial representation instead. So we are really lucky that Jane came to Boulder back in 2001. And here we have to thank Dick, who's sitting next to Jane.
I have to say, I did it for the good of the university.
You've done good. You've done good. So in 2018, Jane wrote a reflection piece. She was invited to write a reflection in the annual review of sociology. I'm quoting her here. I was introduced to Richard Jesser in 1989, Jane says, on my 50th birthday. It still amazes me that the love of one's life can show up at ages 50 and 65. Oh! Awesome. We are so lucky. So thank you, Jane, for all you've done. Thank you, Dick, for bringing Jane here. Really, really appreciate it. We are so proud to have you here and so honored that you have, I mean, the way you've supported this institute and the Population Center through the years. Thank you, thank you, thank you. So I will hand it back over to Stefan to introduce Deborah. So thank you, everybody.
Thank you, Dick. Very good. Thank you so much, Laurie. Very impressive. We are so lucky to have you here. So let's switch gears. Dr. Deborah Balk, as she's sitting right there, will begin her talk in just a minute. Just a few words to introduce who she actually is. Deborah is a professor of public affairs in the Marx School of Public International Affairs at Baruch College and at the Graduate Center at the City University of New York. She is the director of the CUNY Institute of Demographic Research, and she was a 2016 Andrew Carnegie Fellow. She received her PhD in demography from UC Berkeley and a master's degree in public policy from the University of Michigan. Speaking of research, I could go on for very long because we are working closely together. It's very impressive to work with Deborah to see how she's functioning, how she's operating, how she's actually working with larger groups of collaborators. She's working using spatial demographic lens and perspectives, if you will. That basically means she studies a wide range of demographic and health outcomes, poverty, vulnerability. And the special thing is she uses combinations of different data, non-spatial data, spatial data, GIS environments, remote sensing data in these collaborative groups. And it's very impressive how she takes multiple perspectives and understands perspectives from people from different disciplines, from different fields, and works in these integrative and leads these interdisciplinary research settings, as you will get some impressions about today, I'm sure, and really has this mission to advance the social sciences in general, but population studies more particularly. To give you some background, she has done pioneering work in spatial modeling of urbanization for a long time, and we are still on it. And she is one of the lead developers, or the lead developer of the Global Rural Urban Mapping Project. Some of you might know this as the GRUMP. You know what I mean? And is a co-developer of the first global low elevation coastal zone data sets, the LECZ, which she's talking about a little bit today. So really influential data sets and really a strength in these collaborative efforts to make this happen. Many people have used these kinds of data sets and these databases in their own work and their applied work and have reported about this very often in the literature. She's a co-chair of on the New York City panel of climate change fourth assessment, a member of Society and Economy working group of the New York State Climate Impact Assessment, and a member of the U.S. Census Bureau Scientific Advisory Committee, just to give you 3 examples of her service. What she's doing. Her funding is very broad. It's including NASA, NSF, NIH, the Gates Foundation, the World Resource Institute, the European Commission, just to give you some examples here. She's teaching in map making for policy, population dynamics and climate change, methodological courses, analysis, and spatial demography. Welcome, Deborah. It's an honor to have you. Really glad. At the very end, I want to say, the most important point here is Deborah is a great colleague. She's a great mentor, as I could experience over many years of collaboration right now, and she's a great friend. All right. Thank you, Deborah.
Well, thank you, Stefan. Thank you, Laurie. Thank you, Jane. Thank you, Annie and Angie. This has been, it was, as you know, there was a snowstorm yesterday, so even just getting here was an event. I'm delighted. I'm honored to be here. I this is a place I know somewhat well nowadays, having had the privilege of working closely with Lori and Stefan and Fernando, who's here for some the last 6-7 years on projects, and that's brought me here. So I always feel welcome, and so it's really delightful to be here today. I'm sorry I couldn't give my talk yesterday. These two talks were combined in some sense, and I'll make a little reference to, well, this kind of work fits into that kind of work, which is the mathematical and spatial forecasting of urban population futures and built futures, so work that Stefan and I are doing together. It's a little bit of connection. But before I get started, I also want to do my very brief introduction to my own, how I know Jane. Jane and I met in 1985 when I had just completed my master's degree in public policy, and I was working on a cost effectiveness analysis of the maternal child health and family planning program at the ICDDRB, the International Center for Diarrheal Disease Research. So, and that is where Jane was coming to do her visits with her in her research. And Jane and I have never been at the same institution. And I have never been one of Jane's students, but like so many people who are in that same category, Jane took an interest in me as a very young pre-PhD scholar, was as kind and as impressive as any role model can be. And we heard from Lori all the ways in which she can be, she's got a deeply impressive resume, but I just want to, point out that it was the kindness and the personal nature of her attention and to a very young scholar that really stood out and has continued to stand out. And there weren't all that many women at that time doing this. And so I just, I don't want to go without noting Jane's important role as, a leader, especially as a woman science leader as well. And doing it with, the whole shebang. So anyway, so it's my honor to be here. For those of you on Zoom who aren't from Colorado, I will probably reapply some chapstick because I'm dehydrated just from existing here for. And by final way of preamble, I speak fast. Maybe it's because I'm from New York. I will try to slow down a little, but I can't guarantee it because it's just me. So. Let me start with the prologue and the motivation to this study. There were some pressing questions that we aim to answer. Those on who's at risk of seaward hazards of expected sea level rise and associated flooding, forthcoming in the next, certainly in the long term, but also in the more near term as these things unfold. This work was motivated by trying to enter a policy discourse to put in evidence research that hadn't been in evidence prior. And in our very first stop was the Intergovernmental Panel on Climate Change. This was roughly 15 years ago. And to do that, it also required a lot of retooling and blending methods and approaches to data configuration and using some population data, using some satellite data. The actual method is super simple. I won't talk mostly about methods, but I'll give you enough of a flavor to do this and to give you a sense. And so what I'm going to present is largely descriptive statistics today. These were largely, we have there's a lot of uncertainty in our future associated with climate change, but there is also a good deal of certainty. So as a premise, some of the climate change certainties that we know about. In the coming century, the planet will be hotter. It will be more. There will be more variability in the weather. There will be sea levels will rise. It will be more flood prone. It will be stormier, and in some places that are also stormier and wetter. It will also be drier, and in some places it will just be drier. So we know that's all going to happen. There are uncertainty bounds associated with all of those, but that is where those conditions will take place at a very fine scale. We don't know, but in broad strokes, we can expect this. We also know demographically that the world will be more urban. There's no doubt about that. The future of the next century, this is the urban century. We will become more people will live in cities and towns than they already do. And the world will become older. These are two things that we know with certainty. We also know some other things. Populations will start to decline or have already started to decline, for example, in China, right, recently. But and there are many countries in which the population decline, but I'm not so much building that into this talk today, but I will touch upon some points about aging. So, and here we see, this is just an image showing sea level, the expected sea level rise. And of course, you can see as we get, I'll make the owl do its work. Then you can see, you know, the uncertainty associated with how much sea level rise we have later in the century is much wider than what we have in the near term. We can do that. And of course, in the lower chart, we see population aging, and the fastest growing group is people over age 65. So now putting this in, I had mentioned the IPCC, the Intergovernmental Panel on Climate Change. They do these periodic assessments, and I mean, you guys are in Colorado. Many of you probably have colleagues or know the folks at NCAR in particular, and they're big. A lot of people are contributors to understanding climate science. Those reports, these are intergovernmental and you know, international collaborations. And the very first assessment report, they assess the state of knowledge. It's this body of knowledge that has allowed us to unambiguously say those top points about climate. The very first assessment report was in 2001. And population growth was clearly noted as a contributor for understanding climate futures. I'm not going to go through the whole history of this, but the fourth report, so the third report was in 2001. The fourth, so that's the first time that we heard. There were prior reports. So it's 20 plus years ago, we first heard about population growth. About 25 years ago, we hear the first mention of human settlements. And that was because the work I'm about to present, the first iteration of it, we did it to get it into this report. The way this assessment process works is literature either has to be in a formal, it has to be formally found. So it can't just be in gray literature, it has to be in some peer-reviewed literature by and large. Maybe that's actually with the idea of bringing greater engagement, perhaps opening up now to let also other forms of gray literature, but that was the rules of the game. So in 2000, slightly a couple years before that, colleagues and I started this work on the low elevation coastal zones, and that work was largely motivated by trying to understand urban dwellers at risk. I'm not going to go through the rest, but as I show you these more current assessments, the red bits highlight the role of not only settlements, but urban areas, and then urban settlements and urban systems, both as contributing to understanding impacts, adaptation, and vulnerability, as well as mitigation of climate change. So part of the problem, part of the solution. And then the next assessment report yet to be determined, there will be a special report on climate change in cities. So this work had some larger, you know, it was aiming to fit into this. For the purpose of this report, again, I apologize if you cannot read the yellow, but the yellow here, from the recently published report, the sixth assessment, the key messages from that chapter, the yellow ones are the ones I want to highlight, which are that in all cities and urban areas, the risks faced by people and assets from hazards associated with climate change has increased. Also that climate change impacts are felt disproportionately in urban communities, with the most economically and socially marginalized being the most affected. And that global urbanization offers limited, time-limited opportunity to work toward widespread and transformational adaptation and climate resilient development. And again, a lot of this comes from their assessment of the literature and other bodies of evidence. But largely this work is like a patchwork of case studies and national studies. It's not mostly global work, for example. So I think there's some of the work I'm going to start today with a global picture. So I'm going to take you back to 2007 with me very briefly. So in 2007, we created this low elevation coastal zone, and these are the results from it. We estimated for the first time, 1 in 10 person lives in this LECZ. I'm going to use the acronym for the rest of the time. Sorry. And so we see the continents of the world by the color. The bright orange one is Asia. Those are that's slices of the pie. Most countries with any land area in the LECZ have their largest city in the LECZ. Small island states and deltaic states and their cities were at much higher risk, and I'll unpack that a little bit for you. We also estimated that 1 in 8 urban person lives in the LECZ, and that the city dwellers of Africa and Asia are disproportionately at risk. As we see, we go from here where the proportion across the total population stayed pretty constant in the global north, except for Latin America is in here, but we have the Asia and Africa. the proportions of urban dwellers is much higher than on average in those countries. And this is particularly important because as the demographers in the room know, most of the future growth, maybe everybody in the room, it will take place in the cities and towns of Africa, Asia, and Latin America. So it places this kind of work within that zone in particular. Okay, here's the method, one method slide, well, sort of. Maybe a few more, a little more technical, but the method is simple, but it really does depend on the quality of the data. This is the finest level spatial units for the Vietnamese census. Those are the administrative boundaries, really an amazing census. The underlying resolution, this is, you have to do this for every country of the world. The times between censuses change, every unit's irregular. Some countries have fine data, other countries have very coarse data. It's a pain in the, and there are a whole cadre of researchers working on this. And to date, though, for this kind of data, we really only have observed population counts, and therefore we can derive densities from it. So it's kind of a narrow thematic window. We add on top of that, this was the GRUMP data. As I'll tell you a little bit later, we now use other data to measure urban extents, but the GRUMP data were developed, they're night lights. They're based on nighttime lights. And that's Ho Chi Minh City or Greater Saigon right there in bright red. And then finally, this is the low elevation coastal zone. It's based on the shuttle radar topography mission, which was flown on the space shuttle in year 2000. And that data produced an elevation data set that has been widely used in that data set, and then derivative products also based on digital elevation models. And so those data, and then what we do is assume 10 meters contiguous to seacoast is the low elevation coastal zone. And we transform all these data to a quadrilateral grid. I'm not showing that. So we have a very simple rule about how we transform those irregular census polygons in grids. And then from that, the final thing we do is we create these spatial summaries and statistics. For those of you who use GIS, it's a zonal statistic. And then you can make your zonal statistic with any bounding box you like, any spatially available bounding box, counties, countries. If you have arid zones, you could do it there. If you have, any region any zone you have, you can do this. So from that study, in addition to those pie charts that I showed, we also learned that the LECZ covers 2% of the world's land area, but 10% of the world's population and 13% of the world's urban population. That on average, low-income countries have higher shares of their population in the zone than the OECD countries, with even greater disparities in the urban shares. That almost 2/3 of the urban settlements with populations over 5 million persons are situated at least partly in the zone. So big cities, high risk. And some countries, most notably China, urbanization is really driving a movement of population toward the coast. So you have active policy putting people there. And then finally, we concluded that reducing the risks of disasters of climate change in coastal settlements will require combinations of mitigation strategies, migration, and settlement modification. And of course, now people are starting to look at those empirically and see what's really happening. And we're unable to prescribe those there, but but those clearly became that's where we left it in 2017. I mean 2007, with apologies. Okay, so this kind of data, you can summarize it by country. So this country, the darkest black, shows countries where 10% of the population of each country is situated in these LECZs. And so this is actually, this is based on updated research. And so you might ask, like, okay, you learned all that, like, why bother updating it, right? Like, okay, do it again, why? Well, there were really substantial improvements in underlying data and models. So the low elevation coastal zone data, there have been many improvements, both in the horizontal and vertical dimensions of the digital elevation models that make up that data. And there's a big interest in understanding people below 5 meters and people between 5 and 10 meters, that people who live below 5 meters are at much higher risk. And in fact, cities like New York use the 5 meters as an emergency planning zone. So that's a real policy imperative. And then, today's 5 meters is, tomorrow's as sea levels rise, today's 5 meters is tomorrow's, 7 or 8 or 9 meters, because those zones will, in fact, some of those areas will become inundated. There have been similarly population data and models. There have been many improvements in the resolution of the underlying census data that has led the charge. There are also many new models of for population distribution, and most of them have at least a 2-point time series. Some of them have 4 points, and that becomes really important for understanding change over time, and then using these changes over time for some prediction work. And then finally, and this is maybe still the most uncertain area, but there's also been big improvements in time series since GRUMP, much improved remote sensing data since the mid 2000s, opening up the Landsat archive, higher resolution satellite imagery has led to lots of new data sets on settlement modeling. There's also new classes of nighttime lights, which some people now think do a better job of representing economic activity, which would represent then another variable. And they also represent opportunity over time. And importantly, instead of these new data sets allow us to look at the difference, not just between urban and rural, because we all know it's not a dichotomy, it's a continuum. So they allow us to characterize urbanization along a continuum, as well as characterize the built up by some of the urban areas by other characteristics other than simply their population, such as how built up they are, which is, cities vary in this way. So I don't want to belabor this too much, but we used 4 elevation data sets, we used 4 different data sets for urban constructs, and we used 4 population data sets. And so all of these data sets differ somewhat in their underlying inputs and in their modeling. And the population data set is actually, there's a fantastic review by Stefan and colleagues. Shout out to that paper, check it out. And for anybody interested in using those data, that's a go-to paper. So I'll show you the results of the sensitivity analysis in a few minutes. But before I get to that, I'm going to just walk you through what we decided on as our core data sets. And the core was partly selected because we needed the greatest time series, and only a few of them have a full time series. So this is what now we're looking at Bangkok. We're looking at, this is 0 to 5 meters. This is 0 to 10 meters. This is not a temporal data set. We have 1 point in time. So now I don't think that the pace at which this is changing is as fast as population or urbanization, but might be good for us to be thinking about what we would want to be looking at for coastal flooding, for example, and how we could do a temporal data set of that nature. Some studies still caution against using it between the under 10 meters, but most now endorse at least up to 5 and 5 to 10. So we see some trade-offs, and we try to pay a little attention to that larger under 5 and 5 to 10. So this is what urbanization looks like. Here we've used the degree of urbanization data set, which is this against 1990. The red areas show these places that are called urban clusters, urban centers, which are places of population density of greater than 1,500 square kilometers and populations over 50,000. And you may wonder, I mentioned that this was built on satellite imagery, but the satellite imagery helps reallocate people to these areas, and those are from where the densities are described. Kind of another topic altogether, so take my word for it. On this one, you can read a lot about it. And then there are these areas that we call quasi-urban clusters, and they have much lower population densities, and that's what they look like in 1990 in Bangkok. And I'm very quickly going to show you 2015, so you can see quite a substantial expansion. And finally, let's look at it with the low elevation coastal zone superimposed on it. So Bangkok is a seriously exposed city, right? And finally, we have population distribution, and this is based on it's a gridded population from the global human settlement layer population reallocation model. That was 1990. This is again quite a bit of change, 2015, and looking at over the low elevation coastal zone. And this was largely selected because it's consistent with the other data set that we chose. So we also, now before I'm going to pass by those things. So our new results, they confirmed our original findings. They place roughly 10.5% of the global population in the year 2000 and a little bit more in 2015 as a percentage. But what's interesting now that we can distinguish between these different kinds of urban people is it places nearly, it's placing of the nearly 15% of the urban centers at risk, it's placing another 10.5% of people living in these quasi-urban areas, places that small towns, ex-urban areas, maybe some suburban areas and so forth, places at a lower density threshold. And also importantly, while maybe the largest cities are disproportionately found in the less risky of these two, the 5 to 10 meter zone, these both rural areas and these smaller cities or places that maybe, you know, burgeoning urban areas have about 50-50 in terms of who's in the low, you know, if you're at in the lower risk zone or the higher risk zone. So 60, yes.
Real quick, can you back up? If you do your best guess on that slide, but it wasn't proportion of population, it was proportion of land, spatial land that was rural versus urban.
I'm coming to that.
Oh, you go.
Well, sort of. I mean, it's not exactly the same, but it's a pie chart, but it'll give you the general idea. So okay, so 61% of the population lives in those urban centers. That's the red bar. This compares inside the LECZ versus outside the LECZ. So it's a slightly different, Jason, than the one you asked. But on the left-hand side, we see within the LECZ, much bigger red pie. This is much bigger red bit there. Those are the urban centers. And then beyond the LECZ, and this is the land part. So here we see that the land is like quite astonishing. 12% of the land in the LEC is urban or quasi-urban, as compared to 2% of the land beyond it. So way more land exposure. And these fractions are unchanged. Even if you add in every country, they're largely unchanged. If you add in every country that has no land area in this, you know, that's a landlocked country. So, and the interestingly, these quasi-urban areas, and the reason I keep on like referring to them is we know a lot about cities. We know a fair amount about rural areas and sparsely settled areas. We do not know so much. We really don't know much about these areas that are perhaps in between, harder to classify, but those places occupy way more land everywhere inside the LECZ, and they have and more people. So that's an interesting phenomenon. That's just that urban land has, so that I mean, they don't have more people. I take that back. They quasi-urban, they occupy more land, and so that's just that's the important thing, is that they're more, well, the sum total of them is that it's greater than the urban centers. So now the new results, so that I mentioned a sensitivity analysis, and I don't want to belabor this, but in the upper, I know those of you on Zoom can't see the pointer. These are the different elevation data sets. One elevation data set produces a low elevation coastal zone that gives many more people under 5 meters, and all the others are pretty similar. The 3 others are similar. This over here shows across the top, it's very tiny, with apologies, I can't even read it. So if your eyes are not as good as bad as mine, with apologies. But this shows up to 5 meters, up to 10 meters, and outside the LECZ. And this shows those different elevation data sets. And each point is a population measure. And GPW, the gridded population of the world, gave the most conservative, and the one we hone in on at GHS Pop gives the most inclusive. But what's important here is that the estimates are more sensitive to the choice of the digital elevation model that produces the low elevation coastal zone, than they are to population. And then this is when you look at urbanization, and the GHS Pop concentrates more people in urban area because it uses that built layer to put people there. And the settlement estimates are highly sensitive to which urban construct you use. So if you like this urban problem, please join in thinking about it, because it really does result in different types of estimates. However, I can say that these show changes over time. Urban areas, they have experienced the greatest increase in population from 1990 to 2015. I didn't show that this is just the shares, but if I had shown a growth graph, you would get that. In fact, you would see that 75% of the urban center population in the LECZ, there's been the growth rates are higher in the LECZ than outside the LECZ, 75% percentage point increase in urban centers versus urban areas outside. The fastest growing area are places under 5 meters, also important. And then, and that these global averages are driven by Asian cities, which I'm going to say next. And I think I have this coming, I'll add it if I don't. So the data choices, they really do matter because they lead to some large differences in potential sea level rise, but there's really high agreement with urban centers and rural areas, and less so for those things in between. So regardless of the construct, at the tail ends of that continuum, we do a pretty good job in terms of agreement. So despite these different ways of measuring it, urban areas are at risk, period. So there's despite these differences, every source we looked at shows that the LECZs are disproportionately urban and that urban population is growing at a faster rate inside the LECZ than beyond it. And I would argue that fitness for use matters, depends on your use case. You're looking at change over time. If you have better local data, use it, please use it. Inform the narrative, please. And then there's a paper that I referenced to and the details are there. Just now I'm going to move a little bit to some regional stuff now. And as I do, this study has shown us that the percentage change in the 10-meter LECZ by urban continuum, red is cities, yellow are these quasi-urban areas, and green is rural. The black bars represent the population, the share of the population in 1990, and the solid colored bars represent the 2015. And what do we see? But we see disproportionate population growth in the cities of Asia, right? This is urban Asia right here. So we're going to break that down into 0 to 5, 5 to 10. This is Asia here, urban, quasi-urban, rural. And as we go along, we see, this is 2015. So we see high growth both in there are urban centers, in the population of the safer area, I don't want to really call it that, the 0 to the 5 to 10, and then of the very high risk area. And this is the highest change that we observe elsewhere. And importantly, these aren't just regions, but these regions contain very particular cities. I've shown you as an example, started off honing in on the method map is Vietnam. The next method map is Bangkok. And this is because cities are at risk everywhere, but especially in the Asia 0 to 5 low elevation coastal zone. It includes Bangkok, it includes Dhaka, it includes Calcutta, it includes Greater Saigon. These cities, not only are they really at risk, but they're also in deltas. So that leads me, finally, just in case you're interested, these are the top 10 countries. So this is interesting a little bit because, China and India have a lot of people at risk too. They don't have high proportions, but that's just because they have large populations and a lot of land area, and much of their land area is not in the low elevation coastal zone. And then but we can also look at it by the ranked share of population living in urban. These are by urban populations living in these zones. And of course, here we have small island states, but again, we see prominent on this one, we see Thailand, we see Vietnam, and I think Bangladesh isn't shown, but it would be the next one down on this top 10. It's 11, maybe 12. So we have some really big countries with, like, both Bangladesh and Vietnam have over 50% of their populations and even higher percent of the urban populations living in the low elevation coastal zone. So going from global to local with a slightly different group of colleagues, we're starting to look at asking the question as to whether or not a rapid urbanization of deltas is undermining adaptation to climate change. I'm just going to give a few slides from this before I go and show a little bit about the US. So this study differs because from the global study in that we're using spatial data that also delineates the deltas. We didn't produce these data. These data were produced by Zach Tessler, who was at the time a postdoc at City College. It compares the population of the LECZ that's both in the deltas and outside of the deltas. And you will soon see that it really necessitates a focus on Asia and its subregions, not just Asia as a monolith. And so then, it differs from prior studies. There have been really good studies by geophysicists and others who study deltas and the processes of deltas, but this looks at change over time by built characteristics, and then by looking at these different risk zones and doing it for every delta of the world. So here we find that the LECZ is, it's like the LECZ 10, and that is used here as shorthand for 0 to 10, and the 0 to 5, this is just a subset of this, it differs a little from the way we were presenting it previously. It accounts for 2% of the global land, contains 11% of the world's population, and nearly 12% of the global built up. But the deltaic figures are even more striking because they contain less than 0.5%. They contain roughly 3.35% of the world's land, but the deltaic LECZ is home to almost 4% of the world's population. It's just slightly shy of about 280 million people, and 3% of this built up. So here we see that looking at the concentrations of these deltaic regions, we see that the land area is 2.6 times as densely populated in the LECZ. The deltaic LECZ is 2.6 times as densely populated as the non-deltaic LECZ land in 2015, and it was the non-deltaic land was 4.6 times as densely populated as land outside the LECZ. So very striking density differences, and that the built up densities play a similar pattern with built up. We can see those are the blue graph bars. In the interest of time, I won't go into it. And I'll note that these densities are regionally and locally and by urban rural strata heterogeneous, which we'll look at here. So looking at Asia, so in this graph, we see Asia here. Sorry for you guys on Zoom. I'm just distinguishing between the left side Asia, right side rest of the world. The orange graphic is population densities. Blue graphics are built up densities. And the lightest one shows the population living outside the LECZ. The middle shade shows the non-deltaic portion of the LECZ, and the deltaic portion of the LECZ is the darkest color here. And yes, these densities are substantially different in these places. So Asia stands out with far higher population densities outside the LECZ, 4.5 times as the rest of the world. Its non-deltaic area is its non-deltaic area is 4.6 times as high, and its deltaic is 5.8 times as high. And in absolute terms, Asia's delta also have on average, over 1 million, 1,000 persons per square kilometer compared to less than 200 persons per square kilometer in the deltaic LECZ elsewhere. So the deltas of Asia are very special. Let's look at growth. The growth is highest in the deltaic LECZ everywhere, but especially in the level of built up in the 0 to 5 zone in Asia. So that's not shown, the 0 to 5, but the growth rates are highest in this very high risk area. And when we look at I promised that I would look at regions of Asia. So the growth is highest in the deltaic regions. Again, the orange bars, the deepest orange regions of East and Southeast Asia, that's here and here. Both in population, that's what I'm showing, but we would see a similar thing also with built up. And so that's important because, it allows us to conclude that the Asian deltaic cities are really at risk. When we unpack it, we find that their deltaic regions contain large concentrations of population and built up. Asia's greatest risk, and particular regions with deltaic areas dominating the exposure and the LECZ, and that these are places that have, that are really experiencing a lot of growth in their cities and towns. They're not the mega city. They may already be mega cities, but they're still experiencing high population growth in those cities. And then the considerable variation and the especially high population and built up densities in East Asia deltaic LECZ suggests that both these environmental pressures and the risks are likely to be especially intense in this region. And these are growing areas. And so this really, the environmental and the emissions community are starting to use this term lock-in, and the same concept can apply, if, especially with these deep increases in that we see these large increases in built up and these rapid changes in built up in this region suggests that these cities are being built, and unbuilding them will, we're putting these people in harm's way in the future by what we can observe in the last 25 years. So these are, And I want to point out that these are especially precarious, just in case there's somebody who knows something about sedimentation in the room, please. Correct me if I've misspoken, but my understanding is that when you build a really big city on a delta, you also contribute between that and drawing out water for human habitation and so forth. Those processes between the built up structures themselves and the water requirements of having cities there really lead to increasing sedimentation. And those two things are basically confounding processes that lead to sinking cities as we see sea level rise starting to unfold in these places. Okay, finally, I know I don't have a lot of time left, but I'm going to move from regional to the US. And this is work that I'm doing with a doctoral student of mine who comes to CUNY with a law degree and work and practice in a community lawyer. So it's been a really enriching experience for me to work with a community lawyer on stuff that gets to be a little bit more local. So I'm presenting some of our work in this last bit. And so this study differs from the global study in that we use 4 decades of the US Census rather than the global data sets. And here, because we use the data and because the US Census is really rich, we can look at not just population and land exposures as we did in the global study, but we can look at age distributions, race and ethnicity, and housing tenure. And you might say, I know there's much more in the census data than that. Well, yes, indeed, but we're using the block level data to do this. And that's all you get at the block level data that's consistent over 40 years. So, and it differs from prior studies of the US that in that we use the finest spatial resolution data as the underlying thing, use the very same method that I showed before. And we use these census blocks and then we summarize by county and state as I'm about to show. So this is what the inputs look like for Florida. And as you can see, Florida is, we see the low elevation coastal zone. This is a population distribution of Florida. We see the low elevation coastal zone, lots of Floridians at risk. We see the urban rural classification and so forth. And just for those of you who are census followers, the public law, the census 2020 are a little different, the block level data than prior years because it's just the public law and you can't even look at age distributions. You only have in that data set 18 or over. That's another story for another time. So, states, we can look at the states and counties at risk, and we see that of the 3,000 counties in the lower 48 states, which we restrict this to, that we know that Alaska, Hawaii, and many of the US overseas territories, in the Pacific, Puerto Rico, lots and lots of people at risk. This study presently does not include them. But we know that roughly 13% or 390 of those counties have any land area in the LECZ with more than 34 million people at risk, roughly 1 in 6 person. And the population exposure is even more concentrated with only 55% of the population exposure found in the top 25 counties. So this is a real local problem for a lot of places. This thing below shows the counties and you can see your favorite, you see Florida, the states that are prominent, and the stars just show you which, whether the population has changed over time, but this ranking has been pretty much held for 40 years. So we see that the variation in growth rates, I'm showing here the total population growth rates. The blue bars represent, I think maybe the blue bars represent urban. Each bar represents a decade, 90 to 2000, 2000 to 2010, 2010 to 2020. And then the gray bars represent, the blue bars represent in the LECZ, the gray bars outside the LECZ. The first set of the bars are urban, the second set are rural. And without going into detail, just for interest, for lack of time, there's a lot of variation that we can observe both between race and ethnicity and state. And I'll show a little bit of that in forthcoming. But I can also tell you that exposure differs by vulnerability. It differs by, there's a population pyramid showing population. The blue bars are 1990 and the gray bars are, blue bars are, sorry, can't read my own graphic. Gray is 0 to 10, so it's outside the LECZ, and the blue bars are inside the LECZ. And this is rural population over here on the left side and urban populations on the right side. And the upper one is 1990 and the more square one below is the 2020. No, 2010, as I just said, we couldn't do 2020. But we also see a red line map to represent their big race and ethnicity differences, housing tenure, which I will show, vulnerabilities interact, and there are a handful of them. So looking at the percent of population over 65, this is for all the coastal states. In our analysis, we see that in 1990, 1 out of every 8 person, averaging across all the residents of all the coastal states, was over 65. But from 1990 to 2010, we see an additional 6 million, and it's a small increase in the proportion of the coastal states on average. That's not shown on the graph. But we see that the residents of the LECZ are older than on average, and that this is true both in rural and urban areas. And then 15% of urban residents versus 12% of persons outside of it. So, and I'm going to move on to Florida because I know you're all really interested, right? Well, it is like the go-to place to pick on, sort of. Florida has, pick on is the wrong word, to apply an appropriate level of scrutiny. Florida has much higher shares of older adults, 18% statewide in 1990 than elsewhere in the US. And while nearly 1 million older Floridian residents, while it increases to by another million, the percent of the older adults declines in the state actually in 2010. This is everywhere. But in 1990, 1 out of every 5 residents of the LECZ in Florida was over age 65, with even slightly higher proportions in the urban LECZ, as we see by this little animation going by. Likewise, the state trends, they decline again, like the state trends also, but the annual growth rate of over adults is at 1.6% per year is larger in Florida than elsewhere in the entire coastal zone, perhaps not surprisingly. Race, getting just to the punchline here, Blacks have the highest share of population in both urban and rural LECZs, with about 1 in 5 Black resident living in the LECZ. There's a graph that shows a table that shows the disproportionate nature, and non-white single race, not as measured by single race population, is overrepresented in urban areas with both within and outside the LECZ. So this is a housing tenure graph, and I'll just mention why I'm talking about housing tenure for a second. Subpopulations like by race and ethnicity should be understood in the context of the interactions, like with other factors that build on each other. And housing tenure refers to the legal relationship, right, between households and the housing unit they occupy. And there are really big differences between whether you're an owner-occupied or a renter-occupied housing. And these things really matter when it gets down to climate change, because while owners may be equity constrained and renters can move, we see a disproportionate impact by these types of households. So Black, as we see on the next slide, this slide and the next slide, I'm not going to spend, this takes a little time to walk through this graphic, but the Black, and I know I'm running out of time, so I'm going to go through these more quickly, but white and Black Hispanic residents are overrepresented as renters in urban places, both within and outside the LECZ. And when disaggregated, and this is this point I'd like to stop on for a moment, when disaggregated, Black and Hispanic householders were almost twice as likely than whites to live in urban renter-occupied housing within the LECZ. That's a pretty big difference. This is partly important because, climate change will augment or is already augmenting and accelerating affordable housing costs. And low-income residents are particularly vulnerable in areas that are prone to flooding and other coastal hazards. And low-income householders and renters are also likely to experience storm sea level rise differently than homeowners. So they're also less able to move because they're constrained by their equity. And while renters are often more mobile than homeowners, renters face LECZ diminishing affordable housing options, increasing exposure, devastating sort of climate-induced financial shocks. There's another body of literature that economists are contributing to that show this as well in places like Florida and so forth. And importantly, again, another area of research and applying, that renters are often overlooked in disaster relief efforts. A lot of this has been demonstrated by tornadoes in particular, as there's a lot of tornado research, but with reasons to believe this is also happening, and some stuff after Hurricane Katrina in New Orleans. So renters are often overlooked in disaster relief, from buyouts to managed or cheat options and so forth. So that's why these things matter. Okay, I'm summing up. I hope I have the time for it. I've picked a slide of Bangladesh and a slide of New York for Jane here, and 2 places that are important to her. So I will conclude with lessons for policy and planning. First of all, I think that I'll just put the whole slide up. The lessons for the climate planning needs to include social equity. If nothing like what we saw in the US, assessments have to be, pay attention to these principles of environmental and climate justice that are both distributive and recognitional and so forth, to ensure that plans don't augment or reinforce existing inequalities. And by using data like this, we have an ability to actually track how well they're doing over time. They also should be inclusive, which is an area that, as social scientists, I think really it's an area for us to pay more attention to, and to think about how to be more inclusive in research approaches. It's an area that I don't think, yes, some of us in the room may do qualitative work, may do focus group works, may do, and those of us engaged in climate scenario development may speak to community groups, but a full range of what it means to have engagement in data collection efforts is like a new area that I would encourage us to be as critical and rigorous about, thinking about ways to do it right. Lessons for future research. I would like us to, like the approach I showed here, quite simple, can be used with any spatially delineated hazards. Could be used with heat, drought, wildfires, inland flooding. If we have the spatial indicators of those things, we can use them here in the same way. Notably, remote sensing and environmental data are more and more available, and they're easier to use for those of us who just know spatial tools. It's really not the deep dive it used to be. You don't have to have a PhD in physics to use this stuff. Measures, however, of vulnerability and demographic change are going to come from censuses and surveys. So we really have to prepare as a community on the social science side to work with interdisciplinary methods and perspectives. And some hazards are harder to study, like storm paths are much harder than others. So we have to think of new ways to capture information. And again, the social science community has some opportunities here that we could leverage. The work I presented today was largely descriptive, but we have to enhance the description and move beyond. And that work for the US cannot be done globally. We cannot do that work globally. We don't have whatever is the relevant vulnerability group in any throughout the globe. Those data we're very lucky in the US that we have a rich census that's finally resolved. Many countries do not have such data. If they did, they would be part of these global data collections, but they're not. So that said, though, national statistical offices continue to improve and make their data increasingly available that are thematically rich and spatially detailed. But our data infrastructure is still thinking about like the requirements of the 20th century, and we're in the 21st century. It's a more urban century. It's an older century. If we want to understand processes that are important to urbanization and aging, we need to rethink a little bit about how we collect data and collect and use data. On our national surveys, for example, they're fantastic, but they're not spatially specific in ways that are relevant for some of these kinds of problems. Furthermore, we can use findings from research like this to use place-based findings to help improve our understanding of causal processes. We in the social science community can pay attention to areas of climate vulnerability from the get-go in oversamples. I mean, we know how to oversample our populations that live in substandard housing in the global south. We could look at places living in frail, in ecologically frail and climate vulnerable regions if that were a topic of interest. But we haven't yet merged these things together. Finally, I don't know why this is repeating this slide. Hold on. Before I thank my collaborators, I don't know where I guess my final slide did not make it into this presentation, so that's fine. I do know what the last slide says. It's weird. It looks like it's hidden or something. Is it going to show up? No, it's not showing up. Okay, it's hidden. I'm going to tell it to you. So I encourage people to embrace the main findings. So the evidence here is that all evidence shows that the LECZ is disproportionately urban. period. It's more urban. It is. And in the past 25 years, cities have grown faster in the LECC than outside of it. So it's a pipe dream if we're going to say people are magically going to move away from Miami-Dade County to other places without some serious intervention. All evidence shows, this is actually, we see a little bit of evidence going on in Louisiana, people moving from the very most flood prone regions contiguous to seacoast there. That's the one area. In the deltaic regions of Louisiana, we do see, but the non-deltaic parts of the low elevation coastal zone of the United States, there is no retreat happening. We're moving toward these areas. So to pretend that we're not would be a mistake. So globally that there's high vulnerability and there's a lot of, and globally we need to pay attention to the deltaic regions and the cities of Asia. And in the US, we also need to pay attention to communities of color at risk. This is a clear draw from the US study. And so, you know, I think that this research has extensions to it, can continue to inform planning decisions. It can also inform future population projections, scenario development, and other research agendas. And then finally, we don't know the causes of urban growth. So all of this is saying cities are growing, they're situated in the LEC. We don't know what's causing them. So that takes us back to the demography. You know, we don't know if it's, and the geography of it. Is it through land expansion of existing cities? Is it through emergence of new cities? Is it the role of migration or natural increase, and in what proportions and in which places? We do not know that at the scale that's relevant for addressing and adapting to climate change. So where answers to these would really help both in climate mitigation and adaptation planning. So finally, like all interdisciplinary projects, this suite of research was, my core team colleagues are up front. This was funded through a bunch of resources over there. And I had a great group of research assistants and interns, both from CUNY and Columbia, who helped with it. And some of the works I cited are here. And if anybody wants any details, feel free to reach out to me. You can Google me, you'll get my email, but it's also here as well. And thank you once again for having me. I'm happy to take any questions.
Thank you so much, Deborah. Very impressive. We have some time for questions. I think before we start with questions and answers, just a reminder, there's a reception here among my center. So if you're interested in good food and chatting, that's your opportunity. All right, are there any questions?
Lori.
Deborah, my head is spinning. I'm a little depressed. So my question is, what now? And I know that's not your work, but I also know that you are part of a New York City Committee on Climate Adaptation. I'm wondering if that provides us any examples of how this kind of understanding can be brought into policy. What now?
Sure. So cities are actually really interesting. Like, cities are not exactly self-governing. New York is great. New York has, by local law, okay, many of you know New York is great, right? Like that wasn't, but I didn't mean it in that way. I meant it actually has, in addition to that, there is a local law that requires in a short period of time after the global assessment that New York City undertakes its own assessment. And so that local law, and it's not the only place in the country that produces a local law. And that local law does try to address these questions. It has storm resilience guidelines. It is working on planning. They produce their own climate forecasts. And increasingly, there's talk of thinking what is the climate justice futures? What do those look like under different, with climate gentrification, as it's sometimes termed, or with movement of people, areas that are flood prone now, areas that will become flood prone, what will happen to those communities and so on. And even, and we engage with planners of all kinds, including the demographic planners. And those of you who know state and local demography know that they're really uncomfortable if you go, out more than 30 or 40 years. So this is a real empirical and methodological problem to think about. How can we help cities think about this? Do we adopt a scenario space to think about such issues? Do we scenario space, by which I mean, what if scenario? We say, well, if the future looks like it did here or there, so we can use a long history to inform it. But cities, there are whole networks of cities that are paying attention to stuff. So cities are sort of have their finger on the pulse of it. but I'm talking about largely cities of the global north. Although South Africa is a leading city that, some South African cities have very, Durban has a very strong climate adaptation plan. They're like a leader in the global south. So it's not, we need to look, we need to look around, have regional experts and so on. But cities are pretty well connected, and cities are really interesting opportunities because there are also opportunities for mitigation, like the concentrated environments of city mean, transit and those things, we produce less emissions by urban living. But cities are also taking the adaptation piece really, really seriously. It's the bits in between. So that should worry us, the bits in between. So I know there are three, I'll start in the back and we'll go forward. So,
Thank you. Lot to digest and think about. My question is, in thinking about the really complicated and diverse set of tools you're using to get these data sets and these analyses, I'm curious if there's anything existing now on the horizon that we could use to assess whether cities are acting and
that's a really big question. Yeah, no, that's a quick one. Nope. So there is a movement among the same people that I was just referring to push in that direction, to see how it's like to have metrics and databases for understanding. There is this collection of cities called UCC's Climate Research City Network, and they are really city specific. But again, getting at the adaptation piece is a very specific part, and we have more to do on that front, lots more, but I'm sure it will happen. This is a committed group of people who are paying attention. And the other really interesting thing is adaptation happens really locally. And so capturing it is really hard necessarily. It happens by a whole range of actors. And it happens by people who aren't even trying to do any climate mitigation or climate adaptation, like by housing policy, for example. So it's a hard proposition, but people are interested in capturing it. So, yes.
So thank you. That was great. And great descriptive work is what we need to get things started. But I wanted to think about the next step, which you said we need causal work. And I wanted to ask you, what are the key, based on your descriptive work and what you know, what would be those key causal questions you would like to see answered?
Well, we have, let's just take the aging, let's take a question with that puts aging. Many people choose to retire in locations that will place them at risk. And then they will retire in places where they will age and maybe eventually live alone. And those people are at much higher risk, for example, of the consequences of mortality after a storm, for example. So these are questions that the Health and Retirement Survey could help us answer. If the Health and Retirement Survey is, which you may or may not know, but is a giant in the United States, and globally, it's a model for global surveys. I mean, it happens. Fernando here has a project using HRS data in the US and Mexico, for example. So questions are asked about people's motivations and expectations and savings on where they're going to live in retirement, and then it follows them. So we know where people move to, where they move from, where they move to. So I think I just like we want to understand how people think about savings, or for example, or they think about investments in children. We should be thinking about investments. It's kind of hard to live in a place that's really storm prone and ice prone, and for which in a rural area where as population declines, we may have less infrastructure to support those communities. And so there's even greater, there's already decline in rural areas throughout the world, and there are less social services in those places. So being able to figure out how, that's just one behavioral question. But we know, so we have some of the infrastructure ready to go. We could also look at in places that we observe disasters. We know some places are going to have disasters in the future. We could start putting in panel surveys that would allow us to do some of these things. And we can also use new types of data. We have to be careful. We can't get everything off of cell phone data. In fact, you can get there's a great study in Bangladesh where it showed people moved right after a storm, and then they looked a year earlier and people moved exactly. Do you guys know this study? And people had followed that same migration path the year before because it happened to be right before a holiday. So, you need a good structure as well. But these data can help us think about what those structures are. And I think particularly because we don't have the infrastructure to look at urban places, we really are not looking at the heterogeneity within urban areas. And these inequalities that we see in the cities of the United States, we see in every city of the world. So we need to start unpacking that, and we need better data infrastructures that let us, look and those are a lot of, causal questions will come into play, the same kind of questions that we think about routinely, but with this. Jason.
Part of my question earlier about population versus space, as I was thinking again, urban or rural, and as a proxy for agricultural production, you get a much better way. So if you did those same models, has anybody ever estimated percent of agricultural production within the LECZ for each country? And it's terrifying if you think about in terms of if certain countries, if 80% of their food production is within those.
Right, well, especially in
Has
South,
anybody done that work?
especially, nobody's done it with the ag production in particular. That's to my knowledge. The second thing is Asia, of course, does raise the question of, it's like the bread basket of Asia, the rice basket of Asia. And some of that farming that happens in those deltaic regions is equally intense as is the form of urbanization. So there have been modernization of agriculture in Asia, in the deltaic regions of Asia, have in some ways actually exacerbated a problem.
Okay.
It may have made more food available, but it has also shrunk. It has contributed to increasing sea level, the prospects. So but if you don't ask these questions, we may miss some of these important consequences of them. So a question we in the demographic and sort of geographic community don't pay a lot of attention to is putting population and land together on urban, along this urban continuum, and I think that's an area where we just have to collaborate more to get at questions like this. Yeah.
But Oregonian reds are still okay, right?
Sure. Jane, did you?
Thank you, first of all. Question really is about what it seems is that these low-lying areas are attractors.
Yeah, they are.
And how much of it is the choice of people to move because they are attractive, the choice of people to move because it provides land that wasn't attractive for other purposes, and how much of it is national or local policies that are pushing people.
Right.
So it's the push-pull.
Right. So first of all, a lot of people live, I have a variation of this talk. Why are people living in this place in the first place? Well, these places are riverine, right? Well, cities don't develop overnight, right? So, and the longer our arc is on this, we understand that, that's why this built-in question, lock-in question about Asia becomes really relevant. Lots of, if you look at Greater Ho Chi Minh City, Greater Saigon, Ho Chi Minh City, you look at that, the amount of land change that's happened there in just recent decades has been phenomenal. That city has completely changed. That city is mostly at sea level to start with now. So some of this is like, what are the economic opportunities, right? We can't deny economic opportunity, right? So I agree, this policy question of are we moving people there intentionally and as a government, as policy. And China, there has been some evidence that China has actually intentionally moved people to the coast, into the deltas and so forth. Other countries, it may be more inertia. These things are really hard to measure. Getting the policy piece of this and putting it in spatial terms. I hope there's a political scientist in the room really interested in trying to track that question, because that is really, really hard. But that's a really important piece, as opposed to, people moving for economic opportunity, which is, what's caused a lot of migration in the first place, or moving to where networks already exist. And if these places were populous to start, they only become more populous because people, follow the networks. So that's a great question. We could track places over time and policies over time. We could do more causal work that would look at these things. We can't really unpack the migration piece of any cause so much right now, which is really unfortunate. So, Scott.
Great. Something that seemed really interesting to me that you brought up was the idea that different kinds of people discount the future in different ways with regard bias in who's moving into the vulnerable areas of Florida? In other words, the younger people are like less willing to move to those vulnerable areas and older people are?
I didn't use the word move. I just said that that zone is aging. So I don't know why it's aging. It could be aging because young people are moving out, or older people are moving in, or there's just lower fertility in that region, leaving more older adults in that region on average. So it could be affordable, the lack of affordable housing, and that older adults on average have more REISs from a life course perspective than younger adults. So it could just be who's already living there in those places, like the more affordable housing in Florida is in the interior, not at the coastal zone. So so I don't know the migration piece. And even in the US, I think we can look at migration a little bit with ACS data at the tract level, but we can't do it over time for very long period. We can't go back very far to ask that question. And so then we will have to make spatial assumptions about whether the tract's in the low elevation coastal zone or not. But so, yeah, to answer your question, I didn't actually, but it's, the fact that it's aging, that Florida, the older adults in Florida are even at greater risk than older adults everywhere is, I think a big policy concern. But so, yeah. Yes.
Just something that Jane said struck me more from a psychological perspective, and the surveys, I don't know this literature, but surveys learning about people in that latter part of their lives, their weight, the cost, benefit, like of living in a beautiful place as well, not so much for the economic, like I'm gonna have a good job or opportunities, but just I'm willing to take that risk because this is a beautiful place that I'd like to spend, or not uproot because it's a vulnerable place for my family. There's this.
People are really attached to place. Look at Louisiana, look at New Orleans. So although the Jefferson Parish and Orleans Parish are losing population on average, if people can afford to move back, they move back. So we rebuild, and we in the United States at least have some people like to call the flood insurance management assistance agency. I forget A's assistance. FEMA, right? Well, FEMA, I'm just forgetting. FEA, I think A is assistance. That program, what? Oh, yeah.
Flood insurance, yeah.
No, yeah. So that, right. So, right. No, so but that program, people call it maladaptive. Many people call it maladaptive because it lets people, it allows people to rebuild in places that will flood again and again and again.
Right, but I'm bringing up the point that people making a choice, that they would rather rebuild and enjoy the other aspects of their natural beauty or whatever.
And particularly, this is this may also be particularly an issue. It depends on also people's, what if they need, like if they want to have inheritance for their, ideational ideas about inheritance and so on, but this is true. These may be choices. And I mean, I unpacking the individual action piece from the policy piece is super tricky. But even if we wanted to, but there are some, we do ask people about these things in some major surveys, and therefore it is an area for us. We don't have a policy. We don't have a it's the policy piece that we don't have right now. So we don't even know where there's a climate. There's some increasing stuff at like state level climate adaptations, but like, again, more local stuff, hard to get. But we'll get there. I'm sure we'll get there. We should not be pessimistic. As a NPCC colleague likes to tell me, we should not be so dystopian about this. We should, we can imagine more positive futures, especially if we're all willing to work toward them. So, okay, young people in the room, that's for you. So, well, and those of us who are a little less young, but we're happy to work with you. So. Oh yeah, sorry.
Okay.
There haven't been any yet.
Okay, feel free, Zoomers. I can go back to the, am I visible to the Zoom people through the owl?
More or less. You gotta
Okay.
stick a little bit back.
Okay. Okay, great. Thank you. You're welcome. Thanks.